Everything in the world follows the laws of physics. Ice is cold, fire is hot, thin things tear, heavy things fall, and water flows downward. Everything else is an illusion, a distortion of perception. For decades, illusionists have built their craft on exactly this principle. The most famous stage magician of our time, David Copperfield, made the Statue of Liberty disappear in 1983. The effect was astonishing, and to this day, no one knows for certain how he did it. Thousands of people stared into empty space and witnessed the impossible. But it was a trick, a brilliant one, but still a deception. The statue never went anywhere. People simply stopped seeing it. But what if there are things that need no tricks or stage sets? Things that baffle not only ordinary people, but science itself. Magic. No, this is our world seen in a way we have never known before. Things that defy the laws of physics. We humans love to believe that we understand how the world works. Gravity pulls downward, light reflects, substances behave in predictable ways, and material is either hard or soft or transparent. But the moment you look at these substances, our entire set of rules comes crashing down. Here is a material that absorbs nearly all light and disappears into the background, making everything it covers formless. Here is a substance that flows upward. Yes, upward, and don't ask us why. And here's a thread, invisible, as fine as silk, yet as strong as steel. These materials aren't from the future. They're already among us, and now we'll uncover their secret, substances that defy the laws of physics. What we are about to show you is not an illusion, and that's the most important part. There are real materials and structures that genuinely exist, and even David Copperfield wouldn't envy their astonishing properties. Some might seem impossible to you, but rest assured, everything is real and strictly follows the laws of physics. Clearly, there's more to this world than meets the eye. With that in mind, let's move on to the first item in our collection. At some point, nanotechnology experts came to wonder what would happen if you vertically aligned many carbon nanotubes and pressed them close together. How would such a material behave? The developers of Surrey Nanosystems were the first to come up with a practical answer. They created Vantablack, the darkest substance in the world. Vantablack is a honeycomb comprising millions of carbon nanotubes. However, unlike in bee honeycombs, its carbon cells are empty. Although this structure is quite unique, its most important property is that it almost completely absorbs electromagnetic radiation. What does this mean? It means that it's possible to make an aircraft that doesn't reflect radar signals, optics without glare from scattered light, some new designs, and much more. Don't you see the implications? To fully understand Vantablack's effect, imagine being in an empty room with the ceiling, walls, and floors covered in Vantablack. There's absolute darkness and void all around. You turn on a flashlight, but it doesn't make any difference. As long as a flashlight is pointing sideways, it doesn't light up anything, and you can't even see its beam. You might see your hand and legs when pointing it directly at yourself, but other than that, there's nothing around but a pitch black void. If you pointed the flashlight ahead and took a step, you'd bump into an invisible wall. That's what 99.965% absorption means. Due to this property, we see any object with such a coating as shadowy anomalies against other objects. Its unmatched absorption makes it impossible to distinguish detail, see relief, and shape. Any sculpture coated in Vantablack would be perceived as a two-dimensional silhouette made of black paper. Thanks to the ultimate black body effect, Vantablack has already found applications in aviation, car manufacturing, and of course, space. What you've just witnessed was the uncanny ability of Vantablack to hide an object's texture, blurring the lines between reality and fiction. As impressive as this might be, you might want to hold on to your socks right now, because we're about to knock them off. This stuff sounds totally like something ripped straight from a sci-fi epic. One of the most recurring motives in movies involving time travel and alien visitors is rapid wound healing and body regeneration. For now, these remain science fiction. However, the real evidence suggests that we might be seeing the dawn of such technology. You're about to see polymers capable of rebonding after being severed. Moreover, this reintegration neither involves loss of original properties nor any external intervention. Meet the PDMS SSIP BNB, an absolutely unique polymer with an innate flair for self-repair. Similar to futuristic robots, this material can seamlessly mend itself post-breakage without the need for adhesive, welding, or any other tricks. Developed by scientists from Tianjin University, this elastic polymer has quite impressive resilience. It can regenerate even under low temperatures in fresh or seawater and even in an aggressive chemical environment. While it's too soon to talk today about instantly regenerating human muscles and skin, this new polymer is sure to find applications in robotics, aviation, and automotive production. Imagine a car that can self repair interior linings or a leather sofa fixing its upholstery all by itself. What's even more impressive is this polymer's ability to be transformed into a conductor by adding indium and gallium. Just think about self-repairing electronics. What if you broke a smartphone in half, only to see the two halves join together and merge within minutes, all by themselves, turning into a fully functioning smartphone? The extraordinary properties of PDMS SSIP BNB push scientific achievements into the realm of sci-fi. While many modern materials astound us with their capabilities, we know that their production often involves complicated processes and sophisticated equipment. Fortunately, there are some exceptions where even the simplest processes can yield a super material. The discovery of graphene is one of these rare, almost magical moments in science. You might find it hard to believe that two young Moscow State University graduates equipped with cheap adhesive tape were the first to obtain graphene and subsequently even a Nobel Prize. Yet this is exactly what happened. In 2004, Andrei Geim and Konstantin Novoselov attempted to separate graphite into individual layers using adhesive tape. Multiple tape exfoliations later, they obtained a layer only one atom thick that one could see with the naked eye. This was the first piece of graphene. Further research revealed a plethora of graphene's unique properties. As it turns out, it's an excellent conductor of electricity and heat, and one could modify its properties by altering the shape of the sheet or substrate, which means an even bigger plethora of possible uses. Moreover, being 100 times stronger than steel, graphene is the thinnest and strongest material in the world. Now, this does sound unthinkable, doesn't it? Do you need an extravagant example showing its properties? Well, here's one. A 1 square meter graphene hammock can support a large cat weighing over 4 kilograms, yet it would weigh less than one of its whiskers. Just for the sake of comparison, a piece of paper of the same size would be 100,000 times heavier. Given such unique properties, there is no doubt that graphene would revolutionize the production of electronic and optoelectronic devices, chemical sensors, nanocomposites, and energy storage systems. Further, get answers and see the impossible with your own eyes. In the process of evolution, the alpine ibex and its mountain relatives all over the world have learned to walk on almost vertical walls. Just look how they do it. For them, the death defying moment on ledges as wide as a cash register receipt is just a normal family walk for a patch of grass. Or just look at this incredible scene. A she goat and a baby goat are climbing up the huge flat wall of the dam. The terrible height doesn't frighten them. They find the smallest ledges and confidently move up. They only want to eat the salt exuding on the wall. After the meal, they'll descend. The sight of their descent is mind blowing. Observing these movements unwittingly evokes admiration and amazement. Our consciousness protests it can't be, but we see it is, and our mind bursts with questions. How can an animal on hooves walk on walls at great height in any direction? In the process of evolution, the alpine ibex and its mountain relatives all over the world have learned to walk on almost vertical walls. Just look how they do it. For them, the death-defying moment on ledges as wide as a cash register receipt is just a normal family walk for a patch of grass. Or just look at this incredible scene. A she-goat and a baby goat are climbing up the huge flat wall of the dam. The terrible height doesn't frighten them. They find the smallest ledges and confidently move up. They only want to eat the salt exuding on the wall. After the meal, they'll descend. The sight of their descent is mind-blowing. Observing these movements unwittingly evokes admiration and amazement. Our consciousness protests it can't be, but we see it is, and our mind bursts with questions. How can an animal on hooves walk on walls at great height in any direction? How do they make their amazing jumps with sharp and precise stopping on spots where there is nothing even to catch hold of? What is the secret of such capabilities? The answers are already waiting for you. You're about to find out how skillfully mountain goats use the laurels of physics without knowing anything about them. The main secret of alpine ibexes lies in the special structure of their hooves. They're arranged in such a way that they don't slip on smooth, highly inclined surfaces. The hooves are bifurcated into toes. They're sharp, narrow, and can pull apart greatly. At the bottom of each toe, there is a relatively soft leather sole, and on the outer edges, there's a special protrusion, a rim, which is strong, rigid, but not as hard as bone. This arrangement provides a reliable grip on rocks. The hoof tissue regrows quickly so that the hoof is always in the right condition. The design is optimal, offering the best mechanics of interaction with the surface of stone, crushed stone, sand in various combinations. A surprisingly clever application of the laws of physics. The hooves of the ibex are an excellent tool, and it perfectly knows how to use them. Its skills have been refined by evolution, developed and strengthened by continuous training, literally from the moment of birth. Nature has a knack of creating what seems impossible to us. You've just seen a couple of stories about how the impossible, in our opinion, can be possible and even useful. What about the opposite? Is there something that we think is possible, but the laws of nature say it's not? Does it happen that common sense and our practical experience say everything is obvious, according to the laws of physics it must work, however, nothing works in reality? A vivid example of such contradiction is the story of perpetual motion machines. Now we'll show you two ingenious schemes of perpetual motion machines. They are simple enough, but guessing why they don't work is not easy. Let's start with a seemingly very simple water wheel. According to the inventor, the wheel should spin forever, and various useful equipment can be attached to its axis. The main component in the scheme is a capillary tube. Water rises through it, comes back to the blades of the wheel, drops on them, and having spun the wheel, flows from the blades back into the vessel. The whole thing is then repeated. Note, if the power is not enough, the number of capillary tubes can be increased and all problems with the load can be solved. You may agree at first glance everything is real. Water will certainly rise along the capillary, anyone knows it. Getting on the blade, it will inevitably create a force to rotate the wheel, and so on. Everything seems to be right, but we are all educated people, and we know that nature will say no. It's impossible to create a perpetual motion machine. This is a consequence of the fundamental laws of physics. There is a strange contradiction. It turns out that according to some laws of physics, the water wheel is supposed to spin, but according to others, it's not. In fact, there is no contradiction. You just need to correctly apply the laws of physics. The point is that the force of surface tension, which raises the water in the capillary, will not let it flow out of it. So nothing will drip on the blades of the wheel. So the water wheel didn't work. Shall we try it with magnets? For example, the Macintosh wheel. The idea of a perpetual motion machine with a wheel and a magnet was patented back in 1823. The idea is also quite simple and beautiful. Look, we'll take a wheel with a groove inside and a steel ball rolling freely along that groove. We bring a strong magnet to the wheel, moving in the plane of the wheel, perpendicular to its axis. The ball attracted to the magnet rolls up the groove and the wheel spins, the mechanical analog of a squirrel in a wheel. Naturally, according to the inventor, the wheel will spin forever until the magnet weakens or the ball is worn out. In fact, the ball will just rise a little along the groove and the system will stop in a position of equilibrium. There will be no movement. Nature will say no to another perpetual motion machine. Well, okay, but what about wheels and pendulums that spin for a long time? Shouldn't we believe our own eyes? Do not worry. In such cases, your sight does not mislead you. You simply need to be sure that there is definitely a source of energy. It may be hidden, concealed. If there's no such source, then an external source is somehow cleverly used. It's definitely there. The laws of physics do not lie. People just can't get past the idea of a perpetual motion machine, and sometimes it leads to funny situations. A good example here is Heron's fountain. The description of this fountain, working without any pumps and without connection to any external vessels, came to us from ancient manuscripts. Heron's invention was replicated and demonstrated to the public. Part of the audience immediately mistook the toy for a perpetual motion machine. There's no doubt that even today, even among those who have understood the scheme of the fountain, there will be enthusiasts who will try to loop this scheme and turn it into a perpetual motion machine. Let's see what this famous fountain is. Let's find out how it works. The design basis consists of three vertically arranged vessels cleverly connected by tubes. The upper vessel is the bowl of the fountain. The bottom of the bowl is connected to the bottom of the lower vessel by a tube. If there's water in the bowl, there is a column of liquid in the tube, which, connecting with the liquid in the lower vessel, creates some air pressure above its surface. If the lower vessel is airtight, it will have a pressure equal to the weight of the column of the liquid. Heron's idea is to apply this pressure to the upper part of the middle vessel. It contains water too, and will be pressurized as long as there is a column of liquid in the tube from the bowl to the lower vessel. Now, this pressure should be utilized. To do this, a tube is run from the bowl, from the nozzle of the fountain, almost to the bottom of the middle vessel. Under the influence of air pressure, water rises to the nozzle of the fountain and it begins to work. It looks magical. There's no reservoir above the bowl. There are no pistons or mechanisms, but the fountain works. No noise, just a slight splash of water, and that's it. The most important question is, how long can it work? The answer to this question will once again deprive the fans of the perpetual motion machine of any chance of success. With the correct starting setup, Heron's fountain works as long as there is sufficient hydrostatic column pressure in the tube from the bowl to the lower vessel. This means that with water in the middle vessel and the air in the lower vessel, the fountain will work as long as there is water in the bowl. However, water leaves the bowl faster than it comes, in due to pressure loss and resistance in the tubes and nozzle, and also to evaporation. This difference will always be there. Therefore, the fountain cannot be looped and turned into a perpetual motion machine. We get another convincing proof that the laws of physics are inexorable.